Hello and welcome to episode 30 of Cooking with Unity. Tonight we're going to be continuing our little adventure in making RTSs. So I'm your host Max Moreau, and with me is my tech Philip Wilson.
Yep, I'm still here.
All right. So let's get this going. So the last episode, I'm just going to open up the level we made. We got some balls on the screen. And you can click them, and then you can right-click, and they'll move places. And you can also click and then shift-click, and you can move multiple things together to the same location. So this is already a good start for a little RTS-style command interface. We've got a couple little bugs right now, and mainly, we've got this little stutter when it gets to its final destination, which we're probably going to resolve today. And the other thing is, like, we've got some serious user interface problems here. Like, we didn't discuss this last time, but we've got them. How do I know which unit is selected? Like, right now, this one's selected, and I can tell by clicking, but there's no way to tell by looking that I've selected that unit. And additionally, there's no way to tell where the unit is going to. There's no real good confirmation when you right-click as to you've set a move order for this unit. So let's look at fixing those real quick first. We'll try it a few different ways. So, like, remember on the on our episode about my volume's a little bit high. On the episode about making a tower defense game, which is a very similar genre, we had the concept of selection for our unit types. We had a little menu on the left that we made, and the way I cheated the selection in is just made it rotate. Now, I say cheated, but, like, that's a legitimate option for making something select. And that's something you might use in a game somewhere. And it doesn't look bad. It's very easy to implement. So I'm going to show you another kind of way to do that on this episode. What we're going to do on this one is we're going to actually make the color of a selected unit pulse white, and we're just going to make the material color, just change that, and we're going to use that for our selection method right now. So let's see what we're going to do for that. How do we want to start this? So first off, let's just make a script that makes the color pulse so that we can see how that works, and then we'll figure out a way to make a script or how we're going to organize it for the selected units to pulse like that.
You know what would be another cool selection idea?
What?
A spotlight.
Spotlight over them?
Yeah.
That actually would be really easy to implement.
Yeah.
The big problem with that...
I like the color pulse better, but...
I'm glad you mentioned that, because that is actually totally a way you could go. And actually, if you're doing vertex lighting, you can probably get away with it. Lighting is typically expensive. Even the most basic lighting can be considered expensive. And so having a real-time light just to do that could be a problem on a mobile platform. If you're not worried about mobile, that would be perfect. As a matter of fact, it would be super everywhere. Easy. Yeah, you could even just have the lights already pre-populated on all the units and just turn it on or flash it or whatever. But we're going to do it using material in this one, mostly because we don't work enough with materials in my show because it's not really art-based. So I want to kind of bring that in a little bit. Yeah.
Going on.
So let's see. We're going to just do... we're going to make one called just Flash material.
Defender of the universe.
Flash. Oh.
You'll save every one of us.
All right. So what we're going to have here is we're just going to do this on the material for the object. We're going to assume that it is a diffuse material. We're not going to do anything fancy on this one. So we've just made two assumptions there, that it's just going to be on this object and diffuse. So let's make a public float flash delay, or rate. I'll go with rate. I don't think rate's the most appropriate term for what we do, but I'm going to do it. And we're just going to make it 1.0F. And then in anticipation of what we may need, I'm going to put a private color.
Color.
Yeah, private color.
Color. You could call it color.
I could call it color. I'm going to.
Yeah.
Private color.
Private color.
And what this is actually, I'm not going to call it color. You confused me. Original
Oh, okay. Good
color.
call. Good call.
And we're just going to force it to white on this one. We're not going to worry about we could do a custom color, but we're just going to do white for right now. So, but the original color there is so that we can get back to the original color once we've pulsed white. There's no place where it's stored somewhere for us. We just need to store that for ourselves. So on the start, let's just get that original color working. So what we're going to do is we're going to grab renderer dot. Actually, sorry, I'm doing it backwards. Original color equals renderer lowercase dot material dot get. Actually, texture I can probably do main texture. Dot color? No. Wait, actually, maybe it's some material color. There you go. So render.material.color. So this just at start stores that for us. So now what we're going to do is, and actually I'm going to be safer about this. I'm going to use shared material here. So the difference between material and shared material is material gives you an instance of the material for just that object. And in doing so, it actually duplicates the material that's on the object. Normally it just shares the same material, which is what shared material is. It actually duplicates and creates a copy of it, which breaks what is it called when you queue things up?
Dynamic batching.
Yeah, it breaks dynamic batching. Thank you very much.
Mm-hmm.
And so what that means is an object that would otherwise have been batched will no longer be batched and will be drawn separately of the other objects. And that extra draw overhead can cost performance. Anytime you do renderer.material.anything, you have created that copy. It is immediately broken from that. So, so we're going to work with shared material. Oh, wait, we can't do that.
Because that would require all of them to be using the
That
same material.
require all of them to be using the same material.
I think they'll batch, though, again once you get the same color. Really?
I don't think so. All right, we're going to do it in the simple way first, just with material. Sorry, I'm dealing with this on the show, but it's important information. We may switch to a shared material system. Basically, what we'd be doing in the shared material system is... this is probably not a good system for that. What we could do is we could have basically a flashing texture, but we need to have one for each texture that you had, and then we could have that as a separate thing. And we could set that up programmatically so it wouldn't be like a whole lot of detail work, but I'm probably not going to do that on this show.
Couldn't you create like a singleton to assign that material?
Well,
like a separate material to that object?
You could. The problem is, say we have more than just our little green objects. Our green objects are going to flash white. Actually, I guess what we could do is you could have two materials on each object,
yeah,
and then you could use the other one and just alpha it in or something. Maybe we'll do that. I haven't actually done that before.
Yeah, just assign another material to that object.
It does mean double rendering for everything, but that's not a big deal. Double passing, I mean, it's basically double rendering. Let's just do it this basic way first, and then we'll explore that maybe later.
Yeah.
All right, so render.material.color. So this is actually going to be breaking our batching here, but we'll worry about that later. So all we're going to do, I think, is invoke... it's actually probably should be a coroutine. Yeah. Start coroutine. And it will be... We'll just call it Flash.
Took me a lot to resist.
Yeah, I know.
The Defender of the Universe
yeah.
thing, and I even couldn't. Obviously, I had to bring it up.
Yeah.
I apologize for my Queen references.
Hey, nothing wrong with Queen. Flash. Alright, so what we're going to do here is IEnumerator. I shouldn't have done void. IEnumerator, because we're doing a coroutine. And so this coroutine is going to run, it's kind of its own update loop. And what we're going to do is we're going to make up a variable, float t, to store our time information for this. And we're going to set it to 0. And then we're going to, while t is less than 1, f, and actually I'm going to put some spacing in here so it's more readable, and get rid of that erroneous semicolon. So we're going to be tweening the color, and there actually is a lerp for color built in Unity, which is nice, and that we're going to be using that. So we've done lerps on Vector 3. It's just a linear interpolation, and it just, you basically give it a beginning state and an end state and a time, and the time is between 0 and 1, and whatever, if you're at 1, it's at the end state, if you're at 0, it's at the beginning state, and if you're at between there, it magically picks something that's appropriate in between. Color lerp works exactly the same way. So we're going to do renderer.material.color equals color.lerp. Color A is our original color. Color B is, we're going to be using white, so color.white. And float t is our time, so we're just going to put in t. So we need our flash rate in there. So actually, we're going to t divided by, wait, no. Yeah, t divided by flash rate. I think that's right. If it's not, we'll find out shortly. Yeah. And that, oh yeah, okay, t plus equals time dot delta time. And then at that point we're going to want to, oh yeah, we need to yield return null. So what this will do right here is this will get us almost all the way to white, potentially all the way to white, and then it will be done. It'll fall out of this. This will stop happening. But we actually want it to happen basically forever. All right, so the way I'm going to organize it on this one is, so we start the coroutine, so this would fall out. We're actually going to want to make sure that it's actually white at the end of it. So we're going to set the renderer.material.color explicitly to color.white. And the reason we do this is because this could potentially, like, t could be 0.98 here, and then the next frame it could be 1.5 or something, and so we'll skip this, and so it'll never actually be at white. So this actually puts it explicitly there. And then at this point we're going to actually start. I'm actually going to start coroutine. We're going to start a new coroutine. I'm going to call this one return. That's actually probably going to be a bad thing to call it, but we'll find out real quick. So we're going to make another IEnumerator. Return. So this one will bring us back down to where we were before. And the reason I'm doing it this way is, again, so that this makes it so that we can adjust the flash rate while it's running, and it will actually take effect on the next time that it flashes. It also makes it a little bit more easily understood as to what's going on here. We could have made it into one big function that just kind of loops on itself forever, but this will be a little bit more explicit. So this is the same thing, except for we're just swapping original color and white here. Just doing the copy-paste janky stuff here. And then we set original color here at the bottom. And then we switch it back to flash. So, yeah. T plus equals time to delta time. That's probably not right, is it? Because... Alright, so I'm not doing this right. We need to actually change this a little bit. So, we need T to go to... Well, T is less than our flash rate, actually, I think. Flash rate... And then what we do here, T divided by flash rate. Yes. Yeah, this is actually what we want. So this will provide a 0 to 1 here now that we've got the constraints right. So I'm going to hit save, and we're going to give this a shot on one of our balls here. I'm just going to pick one of them and throw it in there. Did it actually go on there? Cool, you can drag it into the scene like that. So if we hit play, one of our balls should flash. There we go. It's flashing.
Oh, yeah.
And I'm going to go ahead and adjust this to be a slower flash to see if that works. So if I do 5.
Look at it go.
Okay.
Totally works.
Yep, it's working. Yeah, that looks like about 5 seconds. So it does... It's doing 5 seconds in, 5 seconds out, which we might want to change that. Maybe. I don't know. I'm going to leave it for right now. So if you set 1, it'll actually take 2 seconds for the full cycle. But the initial flash will take 1. So I'm going to set it to like 0.1. Let's see how that looks. Oh. Let's see if we can crash Unity right now.
Yes! The computer's not crashed, just Unity.
Yeah. So you don't see it here because I've got a virtual mouse cursor, but there's Beach Ball right now. And my fan is getting louder. You can probably hear that. And louder. I'm going to go ahead and force quit Unity here. So luckily we didn't really do anything with the scene. So all of our stuff on the scripting side should be done. The only thing that we missed was attaching that object. Oh, come on. I hate this sometimes. Oh, it's not a real window, that's why. Alright. We're back in this thing. Let's get this window where I actually want it. There we go. Alright, so let's see. We hit play, and we don't have a level load, so I'm going to load a level. And we're going to drag in our flash material onto our ball. And I'm going to click him. We're going to set it to like 0.5. I don't know, something in there.
Okay.
There we go. That looks like a little selection thing. Alright, so now we have a little system for flashing the things. Let's actually see what we can do to make it specific to what is... to what has been selected. So... what I'm going to do is I'm just going to duplicate this, and we're going to call it flash if selected. And we're going to change this to flash if selected. And basic unit movement. So we're going to need... This isn't it. Where is... Alright, so we need to get our player unit manager, so we're going to be doing this thing again. So we need a private unit manager, and we're going to assign that at the very start. Alright, so in this case, we're not going to start a coroutine flash just yet. We are going to take that out of there, and we're going to get an update loop going on. feels like I'm quiet now. Do I just change my own volume over time or something?
It's possible.
Was I getting quiet? Okay. So, update. So what we're going to do here is we're going to check to see if our unit is selected, and if it is, we're going to flash. So, is it easy to check this? So right now we've got a manager for our units. We've got this unit manager thing here. And it has a list of units that are selected. So we need a good way of checking to see if our unit is selected. So I'm going to make a public void is selected, and it's going to take a game object unit. And hopefully there's a way for us to check this real easily using our list here. So let's see. Let's look at our selected units and see what we can do. Selected units dot contains. Perfect. And we're going to put in unit. So put some brackets around it. So if selected units contains unit, return true. And we're going to have to change this to a public bool is selected. And then else return 0 or false. So what this will allow us to do now is if we just check to see if we're selected, so we'll just do if unit manager object, which is our reference to our unit manager. Unit manager. That's what it's called, right? Oh, just unit manager. Okay. Unit manager equal dot is selected. That's probably well, it'll work. Is selected game object. So this will return yes if our game object is currently in the selected list. So if it's selected, we then perform our flash thing. So we will start our coroutine flash. Start coroutine flash. And then else we will stop all coroutines just to be safe. All coroutines does not stop all coroutines everywhere in the universe. It actually just stops the ones that are on this object or in this script specifically. This object could have other coroutines on it that will continue to run if they're in another script. So we stop all coroutines. And then the other thing we need to do is we need to return the color to the original color. So we'll do renderer.material.color equals original color. So hopefully, if we just throw this on our, oh, we don't actually have a prefab for these players yet. That's kind of terrifying, really. I'm going to go ahead and grab one of these and throw it in here. Going to delete these. We're going to grab this guy and put not unit manager. Let go. Flash if selected on our player unit, and we're going to put a couple more in the scene, kind of back where we had them before. Alright, so now if we hit play, in theory, if I click one of these guys, they'll start flashing. Null reference exception, object reference not set to an instance of an object. Unit manager. Oh, I missed a line. I forgot we did this in 2 separate lines because we had a problem at some point. There we go. Now this should work. Hopefully. So we click on it, and it's selected. It's amazing. And we click on a different one, and it's selected. And we click on a different one when it's totally white, and it immediately goes away. And we shift-click, and they both are doing it.
It's pretty snazzy.
That's pretty amazing. I love making things.
Should make them flash and sync, though.
Well, that's something that will get automatically if we switch to a shared material system. So
that's true.
Which we probably will. Maybe we'll do that now. Because I know I mentioned that this episode we'd be doing drag select. We're not. That's already through the window. I specifically spent 26 minutes setting this up so that I could be like, oh yeah, I have no time to do that. But I had no intention at the start of the episode. They don't know that though. Oh, good. Oh wait, they know it now.
Yeah, did you just say that out loud?
No. All right. So we have our units and they're selected, and that's awesome. And we can multi-select them, and they don't flash and sync, which makes it. I kind of think is cool, but at the same time, it's not what you expect out of a game. Honestly, like it would be considered a polish issue by some people, including myself, and including Phil.
Really?
Yeah, maybe.
Do love polishing.
Yeah, we do. We like doing that. We like hurting ourselves as much as possible on games. All right, so let's actually add an object to when we send a move order, so that you can see that we sent the move order. Maybe even just do a particle effect where it happens, just a one-time thing. Because like if you see most games that are RTSs, they usually just have like a little arrow thing or some cool little icon show up there. The only other time that they show it, and actually we should make this too because that would be really cool. I like games that when you hold shift, it shows all the orders that are currently active. So what I mean by when I say that is I like Supreme Commander and Supreme Commander 2.
Yeah,
I really think Supreme Commander 2 is my favorite RTS of all time, easily. And they just have really cool UI ideas like that, where they just it's easy to work with and stuff. So yeah, in their game, if you hold down Shift, not only is it used as the modifier for selecting multiple units, but it instantly shows all the paths of all the units right there. So let's at least get a little particle effect or something going for when you do that. And actually, let's make it a particle effect. I don't think we've played around with particle systems too much on this show, so let's explore that. So I'm going to create this particle system, and it'll just start playing here immediately. It only does it when you have it selected, so but it'll simulate and show you how it looks. And so when you just choose particle system, you get this thing that just like makes balls that shoot upward, or actually forward. I forgot we had organized this. Wait, no, not forward. Yeah, forward. Yeah, this orientation is just very awkward for some reason. Why would they do that? I'm going to OCD that to a 0. It started at negative 90. Why? Why would you do that? Why? All right, so we've got a bunch of options here. So you could spend weeks playing with this and still not learn it all, and that would not even include texture mapping this stuff. Like, you can make some very good effects with a particle if you do the texturing right for it. So what we're going to do, though, is we're going to basically make a little explosion type effect that does this. So I'm going to first start with, like, the first thing I usually change on this is I change it to a sphere. So normally it defaults to a cone, which is directional. Sphere is not directional. And so now you've got little particles going in a circle. And actually, if you focus on this thing, if I hit F a couple times and zoom in on it, I don't know why the focus is not focusing on things very... Why would it do that? Why? Is it like focusing on one of the particles or something? Okay. You'll actually see that it's actually spawning from this sphere. And you can have it emit from shell, which guarantees that it goes just from the outside, or if you don't, it comes from anywhere in the inside of the sphere. So I'm just going to bump this down to lower, so like 0.1 or something, so that we have kind of a very condensed place here. We're going to make this be a one-time thing. We're not going to make it a loop. We're going to hit stop and simulate real quick. So by default, it lasts for 5 seconds, and the duration is 5 seconds. So like each of the particles will live for 5 seconds after the last one's created here. So so that's that. So we're going to make the duration much shorter. Like we might even make it just 0.1. So we're going to simulate, and that doesn't do a whole lot, does it? Maybe we'll make it a half second, 0.5. So there we go, it just does that. We're going to make the lifetime of these things shorter. Probably 0.5 is appropriate there too. And we're going to make the start speed a little bit lower. Let's start at 1. So now if we simulate here, we just get a couple particles that kind of shoot out in either direction. And so we're going to change the emission rate. This will make it so more particles will shoot out faster. So that's looking more like an effect. We're not going to make it. We're not going for anything specific here. We're just kind of playing around with this. But this is another option that you have instead of just having to manually move things around. This is a really well made system for creating effects that you want to reuse. And let's make the color red for right now. I don't know why.
I'm always happy with red.
Phil raised his hand in triumph.
Yeah, I do love red.
Wearing his red shirt.
Yeah.
And
yeah, I like red.
And so I like red for movement just because for whatever reason that's been kind of established as a movement thing. I'm not sure if you noticed in a lot of games the move orders are red when you right click them. I know maybe it's just the ones I play. I don't know. But
fair enough.
It seems like it shows up a little bit. And so now I've got this little like poof thing, I guess. We could play around with it a little bit too. Let's actually make it. Let's change it so you can do size over lifetime, and this has just a little curve editor here, so we can just make it so that these things become smaller over time. So, whoops, that's not what I wanted. So now when you hit simulate, they all kind of become smaller over time. There, it's kind of a cool effect actually. That looked better than I thought it was going to. Alright, there's a bunch of things here, but we'll just go with that and call that our little movement effect now. So we're going to call this move effect. So I'm going to throw that in here. And we're going to go ahead and just put this into our move selected units on right click script here. So we're going to send the message of the move order and the click position. So we already have our click position here, so this is super easy. All we're going to do is we're going to add a public game object move object. I call it that. Or move effect, move object. I'm just going to call it move object. Move effect object. All right. And we're going to instantiate move effect object, click position, whoops, click position, and move effect object dot rotation. No, dot transform dot rotation. And so now, if we hit our plane, which has our move selected units on right click, we're going to drag our move effect in here, and then we're going to hit play. And now when we right click here, it doesn't do anything. If you select a unit and then right click, we get our little move effect.
Neato.
And so now there's a little bit more of a user feedback to that. Interesting to note, most really good RTS games that you might play or talk about are multiplayer. And one of the tricks that they do to make their games feel really responsive, even though they're not very responsive in multiplayer, is to make a lot of the stuff happen locally that has nothing to do with anything. Move orders are a really great example. They make the icon go, and they make the sound, and like the unit will be like, yes sir, or whatever, or it'll just make sound or something, and all that'll happen the moment you click. But then the units don't actually move until they're confirmed on the server and stuff, and so that masks that lag between things. You notice it still sometimes. Like StarCraft is a really good example if people are old enough to remember that game. Because at the time that game came out, everyone was still up on dial-up for the most part, and you'd play and you'd have really heavy lag, and you'd see it. You'd order a unit, and then like 5 seconds later they would move. But you knew that the order went in because you got all that user feedback. So that's really important to give fast user feedback so that they know that they haven't done anything wrong. Operating systems are slowly starting to figure this one out too, though I still see a lot of times when I'll click something and then have to wait 5 seconds for anything to happen without any confirmation whatsoever. So now we've got multi-select, and they all move towards there, and it actually only spawns one of those each time. Now, you'll notice that our move effects are staying around forever. We can, there's two ways we can deal with that. We can make our classic script, which I'm going to make because we always need it. Destroy on invisible. I know we've written this one several times, but it's just one line, so I like to do it. So, 3 lines, technically. Void on became invisible. Destroy. So, for whatever reason, the old particle system, and please correct me if I'm wrong on this. So, our new particle system, the Shuriken particle system, which is what we actually used, is the default one that you get. There's no option that I was able to find anywhere that actually destroys the particle automatically at the end. There was actually a way to do that on the old particle system, where it basically was a flag where you'd be like destroy after it's done. And so that doesn't exist anymore, but you can easily create something that does that too. This one will work in a pinch, and that's what we're... so I'm going to just attach this just so you can see. So if we do move effect now, you'll see that it'll say move effect once we create it here, and then it will go away. No, it won't. Okay, so that does not solve the problem. Good to know. So, destroy on invisible won't work because technically the object is still visible even though it's not rendering anything. So we're going to remove that component. So, here's the real way to do it. Destroy particle effect when done. I'm going to just say that. This one's another short one, though it is an update loop. So, if particle system dot is playing. Actually, we're going to do if not particle system is playing. Destroy game object. So this assumes that whatever object we're attaching this to has a particle system on it. So we now attach this to our move effect, and now hopefully this will solve our problem. So when we click this unit and right click, move effect, and it went away. So good. And actually if we click multiple, I'm curious about this, this should just do 1. No, it created 3 move effects. Let's actually look at that real quick. Move selected units on right click. Alright, so that's because we put it in our for each loop for our unit. So,
you could just have it after the for each loop.
If we do it after the for each loop, it will happen even if you don't have a unit selected. So,
good point.
We are going to do that though. But we're going to still have to put a test here. So, if... Actually, I'm going to have it just set a flag thing here. Bool units selected equals false. Unit selected equals true. If unit selected because I don't want to have to ask this thing for a whole new list. I guess the other thing is I could have stored this list and then checked the length of it after that, but this will work just as well. We're technically setting this to true multiple times, but it's such a small operation it really won't matter. So let's give this a shot. So now if we select all three, we should just get one move order poof. Yep, alright. And if we have nothing selected, we get nothing. Good. Alright, let's fix that little choppiness at the end that we do for when the units are moving. I know that we only have things moving on the screen. We're gonna have to add some shooting at some point so it's fun. Because moving's boring. We've been moving things on screens forever now.
It's true.
I can move my mouse around on a screen.
Oh, man.
Why would I buy a game when I could just move my mouse around all day? And broadcast it to the world.
That is true.
Through an internet connection that's not very special, but good enough evidently these days. So what are we going to do? Should we fix that movement thing, or should we add some shooting? What do you think? Do you think we should fix that movement thing, or do you think we should get some red versus blue action going on, get some bullets on the screen, get some units killing each other?
The second one sounds more exciting, but the first one's probably what I would do.
All right.
I'd say the second one is probably what is more exciting for everyone, though.
Yeah,
because I'm more of like it would bug me to have.
I think there's been kind of a low level of excitement on this episode, so I am going to actually push for excitement right now.
That's what you should do.
We've only got 20 minutes left. We might as well get some stuff done. So let's add some shooting code. Let's do a C# script and let's call it shoot at units in range. So what are these guys tagged as? They're not tagged, and they're on a default layer. Alright. What do we have for tags? Do we have anything cool for tags? Bring Unit Manager, I guess we have that. Okay. We'll play around with that later. So, shoot at units in range. We're just going to make this really generic first, and then we'll make it specific to enemies, and then we'll have enemies shoot at players and stuff. So what we're going to do here is we're going to need a public game object bullet. I like bullet for the name, even though projectile probably would be more generic in case you have like lobbing things or whatever. Public game float fire delay. And public float, what is it called? Radius. So, what we're going to do is we're going to do on our update, we're going to do a physics dot overlap sphere. We're going to do for each collider call in physics dot overlap sphere. Transform dot position and radius. I'm going to go ahead and set fire delay to 1.0 and radius to 1.0 so that we have good default values, so that we won't have a 0 there and be like, why is it not working? And it's just a 0. So
no idea how many times that kind of crap happens to me.
Yeah,
constantly. It's ridiculous.
Mine is I always just forget to attach the script. You've seen it happen on my show every time. It's just like,
Literally.
oh, this should totally work. And it's like, oh, why is it not working? Oh, the script's not attached.
I just forgot to attach a reference of a script in my thing. And it's like, why isn't this working? Yeah, apparently I'm just an idiot.
All right, so what do we have? So call. So we're just going to pick one. All right, so we're going to want to make sure that it's not ourselves and not... Is this the best way to do this? What are the other overloads for physics? Physics.overlapsphere.
Could have a check for a tag that's not the player or something like that.
There's a layer mask for physics overlap sphere. Let's actually use that. That's going to be perfect.
Nice.
So we're going to put a public layer mask. Mask. And so we're going to just feed that into our function here. Mask. All right, so what this will do is we'll fill this out in the editor, but we'll be able to basically set what layers this thing actually looks for, and we're going to basically have an enemy layer, and we'll only care about the ones that are in the enemy layer. So the reason we're doing it as a mask rather than just checking enemy is we're going to use this on the enemy units as well, and the enemy units will be checking for player or player unit status. So so everything in here we can assume has already been passed in through the mask, so all of this should be enemies at this point. So at this point, all we want to do is pick an enemy and shoot at it. Because of this, we... for each collider call in physics... Maybe we don't need a for each loop for here. Yeah, let's actually not do a for each loop, because we don't want to do something to every enemy that's in there. We just want to do something to one of the enemies in there. So what I'm actually going to do is I'm just going to have it do it to whatever the first enemy in the list is. That may not be appropriate. We'll see how that works first. So I'm going to do real shorthand here. We're just going to do 0. So that's our collider of one of our enemies. No, it's not. Maybe it is. Oh, there's an extra thing here. So dot. All right, so we have this. We're doing 0 and then dot. So this should be a collider at this point, and it is not. I guess that's too snazzy. So there's a list of colliders, right?
Yes. So you do like for each collider, and whatever the list is.
Yeah, that's what we had set up as before. Yeah, it returns a collider array. So, all right. Well, I'm just going to call it collider enemy array equals. All right. Enemy array 0 dot. Now it's completing properly. I swear that should have worked before.
It might have just needed a moment to think about what it was doing. Sometimes that happens with mono-develop, I've noticed.
No, it's still being
a bug.
pissy there.
Did you tell it to stop?
No, I guess I just can't get away with that. So enemy array dot 0. We're gonna shoot at them. So we're gonna call game object target enemy equals enemy array 0 dot game object. So that gives us our target enemy, and then now we just need to shoot at our enemy. So oh wait, so this we need to make this safe. So I just assume that there's something in this list. There may not be anything in this list, so we need to check if enemy array is .length .length.
Yeah, you should be able to check the length of the array.
Why is this thing doing... Why is it just... You're doing me so wrong, MonoDevelop. I'm gonna hit save. Maybe it needs to save for a second.
Well, it has that red underlining. It doesn't like it when it does that. I've noticed that autocomplete doesn't work when it has like a little red underline. Sometimes.
Right, well,
let it fix itself here.
enemy array dot
Did
length
that
should
help?
be in here now. Totally done. So
That's stupid.
this will totally work. Length. And I think
You just got to have some faith.
I think it is actually supposed to be. What the heck? Oh yeah, that's not doing anything. So if enemy array dot length is greater than 0.
Yeah, it'll totally work.
I don't remember what we had here before.
I'm sorry.
It's not your fault. I don't think we had anything important. So we're going to shoot at this guy. So alright, so what we're going to do is we're going to actually have a private target game object target enemy. Target enemy equals enemy array 0. So this gives us the first enemy in that list and sets it. Oh wait, and dot game object. Alright. So now we have a target, and now we need to shoot at them. So what we're going to do is, in the start function, which I deleted for no real good reason, we're going to do our standard thing that we usually do for shooting. So we're going to do invoke shoot. Alright, so void shoot. And what we've done in games before is we do something like we'll invoke our own shoot function with our fire delay, which I forgot to put up here. And that will be at the bottom of our thing. And then the other thing we'll do is we'll actually create a projectile and shoot it. So instantiate bullet transform.position and quaternion rotation. Let's go with sorry, I just started thinking about something that I want to try sometime, but I don't think I'm going to do it on this episode. Bullet dot transform dot rotation. And we're going to assume that this bullet is a rigid body, and we're going to apply a force to it. So actually I'm going to put the public float speed equals, I don't know, we'll do 100.0f. And so we'll need a rigid body out of this, so we'll do game object instance equals instantiate as game object, then if instance dot rigid body instance dot rigid body dot add force So our vector 3 force is some math. We need math here.
Math.
Yeah, not a whole lot of math. All we need is our enemy position, which is target enemy dot position dot transform dot position minus our position, so transform dot position, and then we put these in brackets. We get the dot normalized. We multiply it by our speed, and we multiply it by time dot delta time. And finally, what we want to do is we only want to do this stuff if we have a target enemy. So if target enemy does not equal null, I guess I'll do just explicit.
That was a good idea.
And we definitely don't want to include the invoke in that. We want that to keep invoking forever. So that happens regardless of whether we have a target or not. But the actual shooting only happens if we have a target. And then the other thing we need to do here is we need to make sure that this is set to null if we don't have something. So else... So if the array length is 0, that's what this assumes, we set target enemy to null explicitly. So this should throw some objects at anything that comes in range that fits that layer mask. Let's actually throw it, put all the pieces together and see if it actually works. So I'm going to set this on our player unit. I'm going to create a duplicate of player unit here, and we're going to call it enemy unit. We're going to set the layer of the enemy unit to enemies. We're going to actually set that now as opposed to just creating it. And we're going to look at our player unit, shoot at units in range, so we need a bullet, so let's worry about that in just a second. We also get a mask. Let's look at our mask. We're just going to do enemies. So that should only shoot at enemies. If you wanted to shoot at multiple types of things, or if you had like different enemy types in here for whatever reason that you need on separate layers, you can select another layer on top of it, and it'll shoot at those things. So we only want enemies. And we need a bullet, so let's make a bullet. We're going to create a little... let's actually do another particle effect for a bullet. Let's just create a new particle system. I figure since we're doing it once on this episode, we might as well play around with it a couple times. Oh, it is 8:58.
Yeah, you can run a little long if you want to.
All right, but I'm going to cheat.
Never hurts.
Yeah, I'm going to run a little long, but I'm going to just actually use our... no, we need a separate one. All right.
Just use a cube.
I could just use a cube.
Not cubes are used.
All right, I'm just going to quickly make this thing... shape, sphere... Start speed 0.1, and make the sphere smaller, and we'll make it I don't know, purple or something. Let's make it purple. I haven't used purple on this show ever.
No time like the present.
Alright. And actually, why don't we do a color over lifetime thing to make it more interesting. We'll make these things fade alpha wise, and maybe we'll make them get bigger over lifetime just to really confuse things visually. That looks too fantasy effect. Yeah, we'll just leave this size over lifetime. Alright, well that's good enough. Although I want it to look a little bit faster for some reason. So let's make it look faster. Does this make it look faster? No, it just makes it look bigger. Let's make the speed higher. No. doesn't feel like it's fast.
I don't know what to tell you.
Let's do no speed. And let's do lower lifetime.
Do a high speed. See what happens.
There we go. That's looking better. High speed will make it too far out.
Good point.
And let's actually make... Okay, that's what we're going to do. We're going to make the radius a little bit bigger now. There we go. That's looking more like a bullet type thing. And actually, let's make the rate higher. Yeah, I can work with that.
I think that'll work.
Alright, so this is going to be our bullet. We're going to additionally need a sphere collider. And we're going to make it the same radius as... Well, that'll be good. Radius 1. I don't know why the center's not right on 0, but it's not. And we're not going to worry about... oh yeah, we need physics, rigid body. We're going to turn off gravity, and so now we should have something that will be able to function as a bullet. So I'm going to delete this. Now that we have a prefab of it, I'm going to go into our player unit and put our bullet in here. And I'm going to make our radius 2. And let's create our enemy unit. I'm going to actually make red for the enemies, naturally. And so we're going to throw this on our enemy unit. And we're going to throw an enemy unit somewhere on the screen that's not within firing range right off the bat. Alright, so if we hit play, I didn't put it someplace that's on the screen. Oh, somehow it's a sub. That was bad. Okay, so that shows up on the screen. So now let's actually make... so this already has shoot units in range, right? And let's actually change this to 2 like I did before. Let's actually make sure all these are set that way. Oh wait, we want player unit to have the bullet on it. And I'm just gonna make sure that this is revert to prefab. Alright, so if we hit play here and move our units into range, we should start shooting things at them once they get within a certain range.
What range is it?
Alright, so it's doing something now. It's doing it wrong, but it's doing it.
How interesting. I don't know what to tell you about that one.
Obviously, I have... So this is obviously a poison unit. I don't know why I made the particle effect look like that, but that's kind of interesting how it looks. Let's see what we did on our math here. So add force, target enemy dot transform dot position minus transform dot position dot normalize times speed times time dot delta time. So this gives a relative direction. What did we do here? I'm going to make the radius bigger again. Player unit, we're going to set the radius to 5. Move it a little bit closer.
gassy unit.
Firefighter that goes in a different direction. Oh, do we have a physics? Do we have a unit? No, we have a collider on it, though.
Mm-hmm.
It very well might just be the fact that it's colliding with the unit in some way that we don't want. So let's fix that real quick. Product setting. As a matter of fact, the way I'm going to fix that right now, because we're not using it anyway, is I'm just going to turn off our sphere collider on it to make sure that that's not part of the problem. I'm going to remove this just so that I don't get confused and think that it has one. I think you can have a rigid body without a collider. We'll find out, I guess. Alright. So, yes, obviously that was having an effect on it. Are they moving slowly towards it? They might be. Alright, so actually I remember something that we've missed here that's really important. Let's do force mode.velocity change. This will make it so that 100 will go a lot longer. And let's try it one more time. I want this to be exciting. It just doesn't feel very exciting. Oh, it's working. Now it's exciting. Yeah, gas that red enemy.
That is more exciting. More exciting than fixing a pop.
Yeah.
Just have them all gas. All gas all the time.
Yeah. Alright.
They're crop dusting that guy.
Yes, they are.
Well, they'd have to leave, actually, to crop dust successfully. But...
And let's adjust the player unit. Actually, these are instantiated already, so this probably won't do anything. No, it won't. We can change it on one of the units. Okay, so we have units attacking other units. Yay. Alright. So, I guess that makes this a night. I'm going to hit stop on this, and we're going to hit save, which I should have been doing along the way. And I'm going to click these little things here. So if you guys have any questions, or if you want to talk, or you just want to, talk about games industry, talk about Unity, talk about whatever you want, email me at pushypixels@pushypixels.com.
Or you just even say hi. Or
Yeah.
just like, hey,
Just
I
drop
watch
me a
your
line.
show.
Drop me a line.
It could
I love fan
literally
mail.
just say, I watch your show.
Yeah, it could. Though I actually prefer you to write more. So actually, no, if you're going to write me, write paragraphs.
Oh, I'd say just
do
write
it.
single letters. Just
All right. I just FF. Just give me a 255. Give me a 255 if you like the show. All right. In whatever base you like. So, and buy Proton Pulse. I'm going to say it again. There's a free version for iOS. There's not a free version for Android. I'm sorry. I'm working on it. And so we'll have that soon. And was there anything else I was going to say? Oh yeah. I've got a Twitter feed. I don't have a screen for this just yet. I could make one pretty quick. Should I do that? Yeah. I'll do that real quick. My Twitter is Dragfire. If you check me on Twitter, I guess I should do the Twitter thing and put an ad here. Dragfire is my online name, and that's how you pronounce it. Just so you know. Actually, I don't care how you pronounce it because it's a made-up name. But yeah, on there I made a little 1-hour game in Unity, and I have a little time lapse linked in there. And I did it for the 0-hour game jam during the time change. And if you notice, my schedule now says PST instead of PDT because we changed our time zones. I hate time changes, but I do like them for the making games in 0 hours aspect.
Yeah, that is kind of cool.
So check out my Twitter, and if you want to check that out, and
you can follow me on Twitter if you want to.
Oh yeah, what's yours? Let's put
at Magma Lemur.
Magma Lemur.
MAGMALEMUR. That's me.
All right, that didn't
that's
quite
kind of
fit.
it's,
Let me
yeah.
make
That's
that
okay.
There we go.
Now it's all tiny.
Magma
wow,
Lemur.
That's ridiculous.
Yeah. All right.
Yeah. If you want to follow me.
Yeah.
Do it.
Is that spelled right? Did I do that right?
Yep.
All right, cool. So yeah, those are our Twitter accounts. So if you want to follow or want to look at stuff on there, I'm trying to get better at posting things and having cool stuff on there. So
yeah, I'm kind of a lazy tweeter as well.
So thank you, everyone, and good night.
Have a good evening.
All right.